Okay, welcome back guys, welcome back to the physics class. And as you know, we have started a new chapter, that is the mechanical properties of solids. And in the previous class we have studied what do you mean by a solid and why we should study this chapter, like for the design purpose and all those things we have to study this chapter. And also we defined solid in a proper way, like we have two definitions, like in terms of molecular arrangement, as well as it is like we have got two definitions of the solids. Then depends upon certain properties, we have classified solids into two, like one is elastic materials, another one is plastic material. So what do you mean by elastic material? We have also studied when the force is removed, or you can say deformation force is removed. If body regains their original shape and size, it is called as the plastic material. If body does not regain their original shape and size after removal of the deformation force, such materials or such bodies are called as the plastic materials. Furthermore, for particular properties, these materials behave like this. So that property, plastic materials possesses a plasticity property, and elastic materials possesses elasticity property. We have defined all those things, and related terms, still some related terms are there. Those related terms are elastic limit, elastic fatigue, elastic after effect. So here I have written elastic limit, elastic fatigue and elastic after effect. We shall discuss what do you mean by the elastic limit, elastic fatigue and elastic after effect one by one. So let us start with the first, that is elastic limit. So let us have first in detail what do you mean by elastic limit, right? So let us understand the concept of the elastic limit, then we will define what is elastic limit, right? So let's first understand. So what I will do is I take a rod, I take a material, one rod, like this, it is a rod, metallic rod, like this, it is a metallic rod, right? We will assume it, right? So we have assumed that it is a metallic rod and it is fixed at certain surface. One surface is fixed aithe tilkondu. Howda? So it is one metallic rod, it is fixed to one surface. Then again we will apply a load on the free end. So we will apply a load at free end. Load at the deformation force. We will apply the deformation force. Yeah. Suppose I will apply 25 Newton of force on this. Initially what I do, I apply 25 Newton of force. So it extends, ಇದು ಒಂದು ಸ್ವಲ್ಪ ಉದ್ದ ಇದು ಒಂದು ಸ್ವಲ್ಪ ಹಿಗ್ತದ ಬಿಟ್ರಪ್ಪ ಲೋಡ್ ತೆಗೆದಪ್ಪ ಅಂದ್ರೆ, if I remove this load, once again body regains its original shape and size. Getting my point? So once I apply 25 Newton, it extends, body extends or changes its dimension. Once I remove the force, then body regains its position. Then what I will do, I will apply the 35 Newton force. Next time I increase the load, 35 Newton of force I apply, right? If I apply 35 Newton force also, then the rod extends until certain limit, until certain extent. Then when I remove this load, once again when I remove this load, so it comes back. So it is nothing but the elastic material. It is elastic material. Completely it is elastic material, right? So furthermore, I will apply the 40 Newton load, 40 Newton deformation force. Then still body extends, body changes its length. Then once I remove the load, it gets back, right? So getting my point. Now what I will do is, suddenly I will change the load to 60 Newton, 60 Newton or 40 I have applied. So let us take 45 Newton. I have applied 45 Newton. So 45 Newton, when I apply the 45 Newton, body extends, body changes its length. When I remove the force, body does not regain its original shape and size. Getting my point? So when I apply 25 Newton, it is coming back. 35 Newton, it is regaining its original shape and size. But when I apply 40 Newton, still it is getting regaining its shape and size. once I apply 45 Newton and I remove the load, then body does not regain its original shape and size. Getting my point? So this force, this deformation force, which when applied on the body does not regain its original shape and size, or you can say it loses its elastic property. It loses its at 45 Newton, body loses its elasticity. Body becomes plastic. Then this force is elastic limit. Getting my point? So you draw this diagram so that I can write the definition. Draw the diagram first. Right, now let me define it. I am going to rub this so that I have to draw the diagram, and hope you have drawn like you have understood the diagram. Diagram is not necessary, the concept is necessary. Okay, so at particular load, or you can say at the maximum load, which when applied on the body loses means it does not regain original shape and size, loses its elastic property, right? So such load or such deformation force is called elastic limit of particular body, right? So elastic limit is the maximum deforming force, which when applied on the body or material, let's say, body loses its elastic property. Elastic property means what? It is elasticity. So this maximum deforming force is called the elastic limit. Is called elastic limit of that body. Right. So I have given one example where initially I have applied 25 Newton. When the deformation force is removed, body regains its original shape and size. When 35 Newton is applied, still body regains its original shape and size. When 45 Newton or 40 Newton force is applied, still body is regaining its original shape and size. But when I applied 45 Newton of force, body does not regain its original shape and size. So that force, which when applied on the body loses its elastic property. So that force is called the elastic limit. Is it clear? Okay. So remember this term, it is very important for your forthcoming concepts. So next is elastic fatigue. Elastic fatigue. So what is elastic fatigue? Elastic fatigue, it is a repeated load. If you take a wire, ನೀವು ಸಣ್ಣವರಿದ್ದಾಗ ಆಡಿರ್ತೀರಿ, ನೀವು ವಯರ್ ತೊಗೊಳ್ತೀವ, ನೀವು ತಂತಿ ತೊಗೊಂಡು ಹುರಿಬೇಕಿತ್ತು ಹೆಂಗೆ ಮಾಡ್ತೀರಿ? ಬೆಂಡ್ ಮಾಡೋದು, ಸೀದಾ ಮಾಡೋದು, ಬೆಂಡ್ ಮಾಡೋದು, ಹಚ್ಚಿಕ್ರೆ ಬೆಂಡ್ ಮಾಡೋದು, ಹೆಚ್ಚಿಕ್ರೆ ಬೆಂಡ್ ಮಾಡೋದು, then finally it breaks out, right? If you in a childhood you might have experienced that if you want to break a wire or break like wire, what you will do, you have done like you bend a wire in one direction, thereafter in opposite direction, thereafter in one direction, opposite, then finally the wire get break, right? So whatever the load you are applying while breaking the wire, repeatedly you are applying the load, and repeatedly the magnitude is changing, right? Initially you have applied much more load, then thereafter you have applied less load, thereafter much more load. Like it is not a constant, but it is variable, right? ಒಂದು ತಂತಿ ತಗೊಂಡು ನೀವು ಬೆಂಡ್ ಮಾಡೋದು, ಸೀದಾ ಮಾಡೋದು, ಬೆಂಡ್ ಮಾಡೋದು, ಸೀದಾ ಮಾಡೋದು ಅಂದ್ರೆ ಸೇಮ್ ಫೋರ್ಸ್ ಆಗ್ತಿರೋಲ್ಲ ಎವ್ರಿ ಟೈಮ್. ಸೇಮ್ ಫೋರ್ಸ್ ಆಗ್ತಿರೋದಲ್ಲ, ಬೇರೆ ಫೋರ್ಸ್ ಆಗ್ತಿರ್ತೀರಿ, ಡಿಫರೆಂಟ್ ಫೋರ್ಸ್ ಯು ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ ಆನ್ ದ ಸೇಮ್ ಬಾಡಿ, ರಿಪೀಟೆಡ್ಲಿ ಯು ಆರ್ ಅಪ್ಲೈಯಿಂಗ್. ಸೊ what's that force? That force is a deforming force, right? So if the deforming force is repeatedly applied on the body, then body will get failed due to the elastic fatigue, right? Due to the elastic fatigue. So elastic fatigue is the phenomena, or you can say it is a process where repeated load is applied on the body so that it loses its elasticity, right? So it loses its elasticity. So here I write elastic fatigue, repeated load. Instead of load, I write deformation force. Deformation force applied on body so that body get break is called elastic fatigue. See, this phenomena you might have observed in your day-to-day life. Like you might have heard that some bridges after the long use, like after 50 years use, after 75 years, they declared as they are not safe to travel. They are not like new bridges ಭಾಳ ನೀವು ಕೇಳಿರ್ತೀರಿ. ಇಲ್ಲಿ ನೀವು ಭಾಳ ಇಲ್ಲಿ ಹಾದಿಕೊಂಡು ಹೋಗ್ತಿರ್ತೀರಿ, ಎಲ್ಲರೂ ನೋಡ್ತಿರ್ತೀರಿ. ಮತ್ತೊಂದು ಸಣ್ಣ ಬ್ರಿಡ್ಜ್ ಇರ್ತದೆ, ಆಕ್ಚುಲಿ ಮತ್ತೊಂದು ಹೊಸ ಬ್ರಿಡ್ಜ್ ಮಾಡ್ತಾರೆ. ಹೊಸ ಬ್ರಿಡ್ಜ್ ಯಾಕೆ ಮಾಡಿರ್ತಾರೆ? ಅದು ಹಳಿ ಬ್ರಿಡ್ಜ್ ಓಡ್ ಆಗೈತಿ, ಅದ್ರ ಮ್ಯಾಗ ನಾವು ಹೋಗ್ಲಕ್ಕೆ ಅನ್ಸೇಫ್ ಇರೋದು ಅಂತ ಹೇಳಿ ಹೊಸ ಬ್ರಿಡ್ಜ್ ಮಾಡಿರ್ತಾರೆ. ಆನ್ ವಾಟ್ ಬೇಸಿಸ್ that bridge is declared as unsafe depends upon the elastic fatigue. Because on that bridge, if you take on that bridge, repeatedly loads are acting, repeatedly deformation force is acting, but it is not a constant, it is a repeatedly variable force. So here repeated variable force, here I will write repeated variable force. Variable force is acting on that bridge. So due to the action of variable deformation force, that bridge becomes weak. It undergoes the elastic fatigue, right? So we have observed one example of this. After long use of the bridges, those are declared as unsafe to use. Means those are not safe to use right now. Like after the long use of those bridges becomes unused because of this elastic fatigue, right? So next one, you might have also heard that ನೀವು ಕೇಳಿರಬೇಕು, ನೀವು ನಿಮ್ಮ ಟೂ ವೀಲರ್ ಆಗಲಿ ಫೋರ್ ವೀಲರ್ ಆಗಲಿ ಶಾಕ್ ಅಬ್ಸರ್ವ್ ವೀಕ್ ಆಗ್ಯಾವ ಅಂತ ಹೇಳ್ತಾರೆ. ಭಾಳ ವೀಕ್ ಆಗ್ಯಾವ ಶಾಕ್ ಅಬ್ಸರ್ವ್. ಯಾಕೆ ವೀಕ್ ಆಗ್ಯಾವ್ರಿ? Because of repeated load is acting on that bike, repeated load is acting that shock absorber, right? So shock absorber ho gaya antirtar no. Yaake hogtavri shock absorber? Because of this elastic fatigue. So elastic fatigue means continuously you bhala gasiya hodrepa andre bhala ankodu hodrepa andre they will experience a lot of force, lot of variable force repeatedly. So they become elastic, they undergo elastic fatigue and they become weak, right? So suspension system, those shock absorbers are called as suspension system of the vehicle. So I'll write suspension system of vehicles after long use loses their elasticity, right? So another one, if I say we can break a wire by repeatedly applying load in different directions, right? So that is also elastic fatigue. Just now I got an example, which will explain what is the example. So directly breaking, breaking of wire by bending it several times. this is also one example of the elastic fatigue. If you bend a wires repeatedly, then it undergo the elastic fatigue, hence it breaks down, right? So these are the two concepts we have studied. Let us have the third one, that is elastic after effect. Elastic after effect. Here only I will write elastic after effect. So what is elastic after effect? So now let us take an example of the same rod what I have placed in a earlier example, elastic limit. If I apply the force, when I remove it, it regains its original shape and size, or you can say that it regains its original shape and size, right? So it is regaining means it takes certain time. It may be in milliseconds or it may be in microseconds, but it is taking certain time, right? If you extend a rubber, your eraser, if you extend it and leave it, it come back to certain position, then after it goes slow, right? Means what? It is taking certain time to regain its original shape and size. That time, whatever it takes to regain its original shape and size, when we remove the deformation force, that particular time period is called elastic after effect, right? So it is a time period taken by the body, or you can say elastic bodies, taken by the elastic bodies to regain its original shape and size once the deformation force is removed. ಹೌದಾ? ಯಾವಾಗ ನೀವು ಡಿಫಾರ್ಮೇಷನ್ ಫೋರ್ಸ್ ತೆಗಿತಿರಲ್ಲ, ಬಾಡಿ ಸ್ವಲ್ಪ ಟೈಮ್ ತಗೋಬೇಕ್ರಿ ಎಲ್ಲಿ ಹೊಳ್ಳಿ ಬರಾಕ, ತನ್ನ ಸ್ಥಿತಿ ಮತ್ತು ತನ್ನ ಆಕಾರ ಹೊಂದ್ಕೊಳ್ಳಾಕ ಒಂದು ಸ್ವಲ್ಪ ಟೈಮ್ ತಗೋಬೇಕು. So that time period, whatever is taken by the body to regain its original shape and size, is called the elastic after effect, right? So elastic after effect is a time period. Here only I write time period taken by elastic materials to regain its original shape and size after removal of deformation force. So it is what the time period. It is a time period is called elastic after effect, right? So these are the three important terms you are going to deal in the future classes, or these questions may come in your theory examination, like what is elastic limit, what is the elastic after effect, what is the elastic fatigue. So just take a screenshot and make your notes so that we can continue further. So hope you have taken on the screenshot and you have written the notes about that. And next very important concept is a stress. You have to understand this very clearly so that like you will get a question from the stress. Istu neನಪಿಡ್ರಿ, ನಿಮ್ಮ ಸ್ಟ್ರೆಸ್ ಹತ್ರ ಗೊತ್ತಿರಬೇಕು. ಇದರ ಬಗ್ಗೆ ನಿಮಗೆ ಕ್ವಶನ್ ಬರ್ತೈತಿ. ಮತ್ತು ನೀವು ಮುಂದೆ ಹೆಂಗರೆ ಏನ್ರೆ ನೀವು ಸಿವಿಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಅಥವಾ ಮೆಕ್ಯಾನಿಕಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಅಥವಾ ಆಟೋಮೊಬೈಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಮಾಡಿದ್ರಪ್ಪ ಅಂದ್ರೆ ದೆನ್ ಇಟ್ ಇಸ್ ವೆರಿ ಹೆಲ್ಪ್ಫುಲ್. ಸ್ಟ್ರೆಸ್ ಅನ್ನೋದು ಬೇಕು, ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. Even for every metals, whatever you are seeing now, they are acting or they are feeling a stress, right? So what is stress? Stress ಅಂದ್ರೆ ಏನು? First ತಿಳ್ಕೊಳ್ಳೋದಕ್ಕೆ ಮೊದಲು, before knowing what is exactly the stress is, we should know what is a deformation force. So first we will study deformation force. We should know what is restoring force. Right? So what is restoring force? Restoring force andre ಏನು? Right? So I'll take an example and explain it. So if I take a rod, circular rod, And if I apply the deformation force F here, and it is a circular, it is like this. This is into the rod I3. I am applying a force here, F. Its cross section is circle. So its cross section is circle, I am showing here. Right? Its cross section is circle. If I am showing like this, it is a circular cross section. Right? So its cross section is circle. So I am applying the force F, deformation force F here. Right? Now, if I am applying the deformation force F means it will changes its length. It will undergo the deformation. Like it is undergoing deformation means when you remove the load, it gets back to the original shape and size. Why? Because of the elastic property. Right? What causing the elastic property? Why it is behaving like the elastic material or the elastic property? There is a force of attraction between the molecules and molecules. Right? Because of that, when the distance between the molecules increases, that force becomes stronger, then attracts each other. All the molecules are attracts each other, then regains. Right? So there is a force there within the body. There is a force which regains, which makes body to regain its original shape and size when the deformation force is applied. If I am applying a certain force here, say 20 Newton, then in this body 20 Newton are applied by the body. Right? In this body itself, body is applying force opposite to this. Here somewhere force is applied and I am making that F dash. Right? So these two forces F dash and F are equal. Right? So this F dash force is built by the body and within the body. So this F dash force is nothing but restoring force. So restoring force, it will be not there. This force will be not there if the external deformation force is not there. External deformation force irilla restoring force irulla. External deformation force bandha internal restoring force irrati. So restoring force is a force which developed within the body due to why it comes due to the external deformation force. And restoring force equal, these two are equal in magnitude. If it is a 20 Newton, then definitely F dash is also 20 Newton, right? But it is acting in this direction, and this F dash is acting in this direction. So I can write restoring force is equal and opposite to the deforming force. Right? So these 2 points you have to remember regarding the restoring force. Restoring force is nothing but it is inbuilt force for the body which exists when the external force is applied. Right? And this inbuilt force, or you can say restoring force, and is equal and opposite to deformation force. Now we will go for the definition of stress. How can we define a stress means? So stress depends upon if the cross section area, I have told you, understand what do you mean by cross section area. So if it is in pen, if I cut this and observe from here how it looks a circular, right? Its area is looking as a circular area. So this section becomes a circle. So that is what the circular sectional area is, or I can say cross section area is. Similarly, if I take something else which is not no examples are there. If I cut anything like I don't have anything. if I cut like this, my body, if I cut like this section will be visible to you. If I longitudinally, if I cut myself, then if you are looking from that side, then the cross section area is this much, right? So cross section area, you understand what do you mean by cross section area? If you section it and see from C to that section, then whatever the area is visible, that becomes a cross section area, right? So here stress means it is see, when you apply the force 20 Newton, when you apply the force 20 Newton, here the cross section area is, if I take the cross section area is F, then restoring force is also 20 Newton, right? Then it is restoring force is applied on whole cross section. If this is a cross section area, restoring force is applied over all the cross section, right? Then stress is restoring force per unit cross section area of the material, right? So restoring force per unit cross section of the material is called the stress, right? So stress is restoring force per unit cross section area is called stress, right? Is called stress. And stress, if I write in the mathematical form, if I write stress is equals to restoring force divided by cross section area, right? So I am writing C slash S, it is cross section area. So deformation force is nothing but the restoring force, both are equal, so I am writing deformation force divided by cross section area. Now so still stress can be written as stress is equals to, see, this restoring force or deformation force, F dash is equals to F, right? So I will write F divided by cross section area A. So this is what the stress is. Right? So stress is, remember, stress is scalar quantity, and its unit of the stress is unit of stress. What will become? What will the unit of the stress? Force is measured in Newton divided by meter square. So Newton meter square, right? So Newton per meter square is the unit of stress. Then can you write the dimension? Dimension of force. Dimension. So this Newton is nothing but kg meter per second square divided by meter square. Right? So here 1 meter and 1 meter get cancelled. Remaining term is kg second raised to minus 2 divided by m. So 1 meter get cancelled. Here m will remain. So kg means it is mass term m. L raised to minus 1, T raised to minus 2. This is what the dimension for stress is. Right? So this is regarding the stress. Just take a screenshot and make a note regarding the stress and restoring force. Okay, let's move to the next one. Types of stress. What are the types of stress are there? So there are mainly 3 types of stress are there. One is longitudinal stress. And second second one is tangential or shear stress. Then third one, volumetric or bulk stress. So we shall discuss what you mean by longitudinal, tangential and bulk stress one by one. So let us first have the glance or first basic idea regarding the longitudinal stress. Longitudinal stress. So what is longitudinal stress? See, longitudinal stress, first we should know what do you mean by longitudinal force. Longitudinal stress study ಮಾಡೋಕ್ಕಿಂತ ಮೊದಲು ನಮಗೆ longitudinal force ಅಂದ್ರೆ ಏನು ಗೊತ್ತಿರಬೇಕು. Longitudinal force ಅಂದ್ರೆ ಏನು? What do you mean by longitudinal force? If I take an object, body, circular body I am taking, see, it is a longitudinal axis, right? So if I take a longitudinal axis is like this, right? And the transverse axis is like this, right? So if the force is applied along the longitudinal axis, longitudinal axis, force may be like this or may be like this. It may be parallel to the longitudinal axis or along the longitudinal axis. Then this force is called as longitudinal force, right? Longitudinal force. Then whatever the stress built up in the body due to these kind of forces. Longitudinal force ಅಂದ್ರೆ ತಿಳ್ಕೊಳ್ಳಿ ಮೊದಲು. Longitudinal force ಅಂದ್ರೆ ಏನ್ರಿ? Force applied on the longitudinal axis of the body. ಈಗ ನೀವು ಪಿಲ್ಲರ್ ತಗೋತೀರಿ, ಆ ಪಿಲ್ಲರ್ ಹಿಂಗೆ ನಿಂತಿರ್ತಾವೆ, ಕಾಲು ನಿಂತಿರ್ತಾವೆ, ಅದ್ರ ಮ್ಯಾಗ ಬೆಲ್ಡಿಂಗ್ ನಿಂತಿರ್ತದೆ ಹಿಂಗೆ, ಹೌದಾ? ಸೊ ಅದ್ರ ಮ್ಯಾಗ ಫೋರ್ಸ್ ಹೆಂಗೆ ಆಗ್ತಿರ್ತೀರಿ? ಲಾಂಜಿಟ್ಯೂಡ್ನಲ್ಲಿ ಅಲಾಂಗ್ ದ ಆಕ್ಸಿಸ್ ಆಗ್ತಿರ್ತೈತಿ, ಒಳಗೆ ಆಗ್ತಿರ್ತೈತಿ, ಬಟ್ ಅಲಾಂಗ್ ದ ಆಕ್ಸಿಸ್ ಆಗ್ತಿರ್ತೈತಿ. ಅದೇ ನೀವು ಏನು ಬೀಮ್ ತೊಗೊಂತೀರಿ, ಬೀಮ್ ಹಿಂಗೆ ಇರ್ತದೆ, ಆಯ್ತು ಲಾಂಜಿಟ್ಯೂಡಲ್ ಆಕ್ಸಿಸ್ ಹೆಂಗೆ ಐತ್ರಿ? ಹಿಂಗಾಯ್ತು, ಹೌದಾ? ಅದ್ರ ಮ್ಯಾಗ ಲೋಡ್ ಹೆಂಗೆ ಆಗ್ತಿರ್ತೈತಿ? ಹಿಂಗೆ ಆಗ್ತಿರ್ತೈತಿ, ಹೌದಾ? ಸೊ ಇಟ್ ಇಸ್ ಆಕ್ಟಿಂಗ್ ಲೈಕ್ ದಿಸ್. ಸೊ ಇಟ್ ಇಸ್ ನಾಟ್ ಲಾಂಜಿಟ್ಯೂಡ್ನಲ್, ಅದು ಲಾಂಜಿಟ್ಯೂಡ್ನಲ್ ಅಲ್ಲ, ಹೌದಾ? ಫ್ಯಾನ್ ನೋಡ್ತೀರಿ, ಫ್ಯಾನ್ ಹೆಂಗಾಗಿರ್ತದೆ? ಅದ್ರೊಳಗೆ ಒಂದು ರಾಡ್ ಇರ್ತದೆ ರೀ, ಹೌದಾ? ಫ್ಯಾನ್ ಇಲ್ಲಿ ಕೆಳಗೆ ಇರ್ತದೆ ತಿಳ್ಕೊರಿ, ಹೌದಾ? ಈ ರಾಡ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರಪ್ಪ ಅಂದ್ರೆ where the load is acting along the longitudinal axis, it becomes a longitudinal force, right? So longitudinal force means if the force is acting along the longitudinal axis along force act ಆಗುತ್ತಪ್ಪ ಅಂದ್ರೆ ಅಥವಾ ಅದಕ್ಕೆ parallel direction force act ಆಗುತ್ತಪ್ಪ ಅಂದ್ರೆ it becomes longitudinal force, right? So longitudinal force may be tensile or compressive. Tensile means force which when applied on the body tends to increase its length. Getting my point? Tensile force means what? Which when applied on the body, it is a tangential force, or you can say which is a longitudinal force. Which when applied on the body tends to increase its length. It is called as a tensile force, right? So tensile force, longitudinal they are ಪ್ರಕಾರ ಒಂದು tensile ಇನ್ನೊಂದು compressive. So tensile, compressive. Right, here I am writing tensile stress and compressive stress. Right, if the force is acting on the body which tends to increase the size, or you can say size of the rod or size of the body, it becomes tensile stress or tensile force. If the force which tends to decrease the length of the body, it becomes compressive force. Then hence the force or the stress associated is called compressive stress, right? So let us define tensile and compressive stresses. Tensile stress it is also force per unit cross section area. It is the force, or you can say it is a ratio of, or you can say simply force per unit cross sectional area. See, when this force is applied, what special thing is happening? Is it's increasing length, right? So force per unit cross section area when body increases its size because of force is called tensile stress, right? Tensile stress. If I take body and if I apply force here, then body elongates, then whatever the force here, yeah. In this situation, whatever the stress develops is force divided by area, which is tensile stress. Right here, the length of the body is increasing. Similarly, if I write the compressive stress, it is also force per unit area, right? It is also force per unit area, but what special thing is happening here? The length of or the size of the body, or you can say length instead of size, increasing the size and written here, we take the length. Length of the body decreases, right? Length of the body decreases. So this decrease in length is caused by the force that is called as the compressive force, and hence inbuilt force or inbuilt stress is called compressive stress, right? So here also I write force per unit area, force per unit cross section area when body decrease its length because of applied force. If because of applied force, what I have written, because of applied force, length of the body decreased, then the length is changed. So whatever the stress built here, whatever the cross section area divided by force is there, that is the compressive stress, right? Here it is the tensile and here it is compressive, right? So here the stress becomes same diagram if I draw, is called compressive stress. Same diagram if I draw here, same rod I am taking, and now the force is applied in this direction. So when the force is applied like this, the length of the body gets changed, right? So if the length of body is decreased, then whatever the stress developed here, that is force divided by cross section area, is equals to compressive stress. So here remember, this tensile stress or compressive stress or simply longitudinal stress occurring because of change in length of the body, right? So this longitudinal stress, from these two definitions, from these two things or these two concepts, what I tell is longitudinal stress comes into picture or comes into body due to the change in the length of the body. When it changes, when the external force is applied, right? So longitudinal stress is a stress or it is a force per unit area. It is a force per unit area when body changes its length, right? Length because of applied force, right? So here I have written it is, so it is not at all written here, so it's a, and unit of the longitudinal stress, longitudinal in that tensile or compressive stress, all are the same as the unit of the stress. So So unit of tensile, compressive, tensile and longitudinal stress same as that of unit of stress, and dimensions are also same because these are the types of the stresses. Unit and dimension not change, right? So take a screenshot so that we can move further. Okay, so let us move to the next tangential stress or shear stress. Here, if I take how the shear stress or tangential stress is, see, if I take a body, this is suppose a box. Suppose a box is here, right? And one surface is fixed and another surface is free. If I apply force on this surface, tangential force. If I apply the force on this surface, if I take an example like this, here it is fixed and here I am applying the force like this, right? So whatever the force I have applied, I am applying. This is the tangential force. Like this, tangent to the surface I am applying. So here tangential surface, tangent to this. Due to this tangential force, body changes its shape. Right? Body changes its shape. Here it is theta. Right? Body changes its shape. Now here. So whatever the force is applied, this is a tangential force. Now, tangential force, due to this tangential force, certain restoring forces are developed. When I remove this tangential force, once again body regains its original shape and size. Right? So due to this tangential force F, here within the body, some restoring forces are developed. So the ratio of restoring force per unit cross-sectional area of the body gives the tangential stress or shear stress. So tangential stress is the stress induced because of tangential force. Right. So what is the tangential force? When the force is applied along the tangent of free surface of the body. It is a free surface and it is a fixed. So free surface of the body, that force becomes the tangential force. So tangential force, when it is applied on the body, some restoring force are induced. So restoring force due to this tangential force per unit cross-sectional area is tangential stress. Right? So here I write first what is tangential force. When force acting along the tangent to the free surface of body. It is what the tangential force. When this definition is of tangential force, right? Due to this, restoring forces are developed. Restoring forces are developed, right? So restoring force, this restoring force, right? These restoring forces develop. So restoring force per unit cross-sectional area is the shear stress, right? So, I am writing this due to these all things. Then, if condition is satisfied, then restoring force per unit cross-section area is called shear stress. Shear stress or shear force. ಏನೆಲ್ಲ shear stress ನೀವು ಏನೋ ಕಡಿತಿರ್ತೀರಿ ಮುಂದಿನ ಏನೋ ಕಡಿತಿರ್ತೀರಿ ಮತ್ತೆ that is what the shearing is taking place. ಕತ್ರಿಯಲ್ಲಿ ಏನೋ ಕಡಿತಿರ್ತೀರಿ ಹೌದಾ ಕತ್ರಿ ಒಂದಕ್ಕೊಂದು ಮೀಟ್ ಆಗೋದ್ರಲ್ಲಿ they are go like this, right? ಒಂದರ ಹಿಂದೆ ಅಥವಾ ಒಂದರ ಮುಂದೆ ಒಂದು ಹೋಗ್ತೈತಿ. So that is what the shearing process is taking place. Shearing means the forces are acting tangentially they are acting. right? ಇಲ್ಲಿ ನಾವು ಕಟ್ ಮುಂದಲ್ಲಿ ಶೇರಿಂಗ್ ಆಗ್ತಿರುತ್ತೆ, ನೀವು ಕಟ್ ಮಾಡೋದು ಶೇರಿಂಗ್ ಆಗ್ತಿರುತ್ತೆ. So that is what the sharing is, right? So when a tangential force is applied on the free surface of the body, then restoring forces developed per unit cross sectional area is the tangential stress, right? So now model varadi due to this, you know, that is good, because to understand that there are certain restoring forces are there, right? But what we need the tangential stress or the shear stress definition, so that I just modify in a simple sentence I have written, right? So next, compressive stress or bulk stress. Compressive or bulk stress. See, first we should know what is compressive force. ಇಲ್ಲಿ ನಮಗೆ tangential force ಅಂದ್ರೆ ಏನು ಗೊತ್ತಾಯ್ತು, ಇಲ್ಲಿ ನಮಗೆ bulk force ಅಥವಾ compressive force ಅಂದ್ರೆ ಏನು ಗೊತ್ತಿರಬೇಕು. So if I take a body, circular body or any shaped body, if force is applied from all the directions, if the force is applied in all the directions, and this force, whatever the forces here applied, these are all equal in magnitude, and these forces are perpendicular to the point. If it is acting here, means it should be perpendicular to this surface. If it is acting here, means it should be perpendicular to this. Or you can say, in terms of normal, or you can say parallel, you can say that these forces must be normal to the surface. All the forces must be normal to the surface, and all the forces are acting in all the directions of the body, right? Everywhere, all the directions of the body, and these forces are equal in the magnitude, right? So all are in compressive in nature, right? So such forces is called the compressive force, or no, it is not a compressive. Compressive we already studied. It is a volumetric. Or the bulk stress, and this force is called, these kind of forces are called bulk forces, or you can also say it as a hydraulic force, right? So hydraulic force is a force which acting in all the direction on the body, such that these forces are normal to the surface, right? These forces must be normal to the surface, and almost all the direction they should act, right? So I'll write the definition of bulk stress. So when if many forces, several force acts on a body in all the direction, and normal to the surface. So this, up to this, it is a hydraulic force definition, normal to the surface. Then due to this hydraulic force, some internal restoring force are developed, right? Then restoring force per unit cross section area of the body gives volumetric or bulk stress. So then restoring force per unit cross section area is called volumetric or bulk stress. See, if you take an example of submarine which is in the sea water, that submarine experiences the same force in almost all the directions, right? In almost all the directions. So submarine experiencing a bulk stress, right? So the bulk stress means it is the ratio of internal force, restoring force to the cross sectional area, but these restoring forces comes because of hydraulic force. So what is hydraulic force? Hydraulic force, if many or several forces acts on a body in almost all directions, such such that these forces are normal to the surface. These forces called as hydraulic force, right? Then due to this force, whatever I have explained here, due to this force, restoring forces are developed. Then the ratio of restoring force cross section area gives the bulk stress, right? So this is the idea regarding the types of stresses, stress, and today we have studied up to the volumetric stress or the bulk stress. So in the forthcoming classes we will enter a bit more of this chapter. So take a screenshot. I will stop it and we continue in the next class.